Okay. Yeah, so the last problem that I discussed with you is when you drop a ball and then it bounces from a floor and then it comes back to half the height and then continues bouncing. So we drew a graph for velocity time when it goes from here to here and till here, right? And the velocity time graph was kind of special. The velocity time graph started this way with 0 and went on this way. Why is it sloping downward? Because acceleration is negative 9.8, right? So this acceleration due to gravity is a constant. When you dropped it, the velocity was 0, but the velocity is increasingly negative. And when it comes here, it touches the floor for a fraction of a second. So it flies up to that position where it bounces. So it's bouncing, it is hitting at a higher negative speed, and it bounces off with a smaller positive speed. So like negative 40, negative 30, that sort of thing. And then what happens is from that moment, once it leaves the floor once again, it actually continues to go until it reaches the top, which is halfway up. And I told you the significance of this graph. This is going to be a negative area, and that's going to be a positive area. The net area is still going to be negative. Look, this is a much bigger negative area, and this is, so I'll call it A over 2. So we have negative area, and that is a positive half area, which means this displacement is negative of something. So if I dropped it from 50 centimeters, this area is going to be 50 centimeters negative, which implies it went through a negative displacement, right? And this area turns out to be a positive 25 because from the floor it's coming up, but only 25 centimeters, half the height, right? So that's plus. So what is the net area? Net area is negative 25, which means for the entire journey, the displacement is negative 25. That makes sense because it started from 50 centimeters, went down, and came back here. It was here, now it's here, which is negative 25. So now how do you draw a displacement time graph for the same thing? How do you draw a displacement time graph for the same incident? You're dropping it from 50 centimeters, it went down and came back here. How do you draw the displacement time graph for the same? Yeah. So you start from here and go down? Yeah. Like this? Okay. Let me stop at this point and ask you. A straight line on a displacement time graph tells you what? Constant velocity, which means this graph tells you it's a constant negative velocity. Was that the case here? So constant velocity, that means from the time you release it, it's going at a constant velocity till down here. Which means what is the acceleration? 0. So what is the velocity the moment I released it? 0. So the line has to be sloped which way? This way, this way, this way. The velocity here is 0, which means the line should be sloped this way, this way, this way. Horizontal. A horizontal line on a displacement time graph implies 0 velocity, and that's the 0 velocity stage. So the line should start off that way. The line starts like this. Why? Because the slope of displacement time graph infers velocity, and the velocity in the beginning is 0. That's why. What happens after some duration, after some time? What is this velocity like? It's a negative velocity. So which means the graph of displacement time graph should be sloped like this, or like this, right? So this is less, it's like -5, -10, -20, -30. And so the slope also will go accordingly. Like this, 0, next, and next, and next, next, next. See the slope is changing? This is negative of 0, -5, -10, -20, -30, -40. And that's when it hits the ground. That's when it hits the ground. As soon as it hits the ground, what happens to the velocity? As soon as it hits the ground, that moment, it suddenly becomes positive. That means it was negative velocity here. As soon as it hit, it changes to positive. That means the slope suddenly becomes positive. Will it be the same magnitude of this? Will it be the same magnitude of this like that? Why? Because the bouncing velocity is actually less than the impact velocity, correct? So therefore, it's going to have a slope, but not that steep. Look. Yeah.
So, is it like actually literally instantaneous, or is it just like the
Almost
slope is so
instantaneous.
steep that it doesn't really matter?
No, the time is so short here. The time is so short. How, compared to the time of fall, that is from here to here, the time taken for that contact is negligible. The time taken for the contact is negligible. How long is it? How long is it actually making contact with the? How long is it making contact with the cable? On the time. The time is so negligible. So you're dropping from here. Look at the time of contact. The time for which it was in contact with the table is so small compared to the time taken for it to go. What is that time? There's nothing. And that is why it's almost instantaneous. It's not easy for you to show the changeover of speeds. Yes, if you zoom in multiple times, it's going to be like this, and then a curve like that, and then there should be a zero slope there, right there. You understand? There should be a zero slope when it hit and stopped, and then starts off again. So the line is supposed to be like that when you zoom it in multiple times, because it was a negative thing, and very quickly it changes to zero, and very quickly it changes to a positive thing. And you can't represent that over here, so that's why I'm showing it as two lines. So this is a flatter positive velocity, that one. And what happens to that velocity as it goes, as time goes on? It becomes less and less. So it becomes less and less and less. What's the velocity right there? 0. And why did this not go all the way here? It doesn't bounce back to the same height. It's only coming back to half the height. And you can see clearly here. This is the full height. This is the total distance it went down, and it comes back up. Okay? So the graph clearly indicates what exactly is happening to the ball. So for this ball, well, this one doesn't actually bounce to half the height. I think it makes it till here. Okay? This one makes it till that position. So this is making it more than half. So it actually comes till there. But the idea is clear? Yes? I'm going to give you another graph. Make sure that you draw it on a new page. So I'm going to fill this up with graphs. So here is So that's velocity time graph. That's velocity time graph. This is acceleration time graph. This is displacement time graph. Okay, here is the velocity time graph. That's the velocity time graph. And I'm going to put some time markers right there so that you can have a good reference. If you have the ruled pages, if you had flipped it like that, you would have had these lines ready for you. If you are actually if you flip the notebook, these lines could be used as the regular lines. Anyway, that's fine. So that is the graph that's given to you, velocity time graph, and you have to, let's start with the acceleration time graph. Let's start with the acceleration time graph. The slope of this line gives you this, the slope of this one gives you this, right? So let's go from here to here. What do you think is the slope from here to here? Positive value? There's some positive value, so I put that. That is a constant slope, so a constant acceleration. Make sense? What is the acceleration from here? What's the slope from here to here? What's the slope? So no acceleration. So at that spot, no acceleration. Zero acceleration. What is the acceleration from here to here and from here to here? So basically from here to this time. Negative acceleration. Compared to this, is this bigger or smaller? Magnitude wise. Which one's got more magnitude of slope? This one or this one? And therefore, and it is negative. And so you go. See that? More negative. This is less positive, this is more negative. Oh, to the view. What is the acceleration? What is the slope here? Zero. So you come back again. What is the acceleration from here to here? Positive. Is it bigger than this? Yes. So it will go slightly higher. It's going slightly higher. And from here to here, there's zero acceleration. And then from here to here, it is a negative acceleration, almost like this. So almost like this. That's the end of story. We don't know anything after that. So this is the acceleration time graph, and you can see how we drew the graph. It is just slope of this gets you this. The slope of velocity time graph gets you the values of the acceleration at every moment. So slope from here to here is a constant slope, so a constant value of acceleration. Any questions on this? Now let's go to the other one. This is a little more trickier. The slope of the graph that you're planning to draw should give you values of velocity. That's how you should think. The slope of the graph that you're intending to draw should give you the values of velocity at different instances. So let's think about the reverse. What's the value of velocity here? 0. So the slope of the line that you're intending to draw should be 0 slope. 0 slope is that. Okay? Now what is happening to this? At this point, what is the value of velocity? Going higher, positive, negative. And therefore the slope has to grow positive. Simple. It is 0 here, and then the slope gradually changes to positive. It's a continuous increase in slope. So at this point, it has got a positive slope. What is the value of velocity from here to here? It's now what is the value at this positive? And what is happening to the value of velocity till here? It doesn't change. That means the slope of this line should not change till here. So it will continue to go in a straight line. So from here to here is curved, and with whatever slope you ended up, it will keep that slope all the way there because the velocity stays the same. So the slope of the line should stay the same. Now what is happening from here to here? What happens to the value of velocity? It is coming down to 0. So the slope of that line should come down to, so that's a positive slope. And then slowly the slope will come down to 0. And so that 0 line, flat. And what happens after that? It becomes negative. So from here onwards, 0 slope, negative, negative, constant slope, which means a constant velocity, constant from here to here, increasing negative velocity, and so it's supposed to have a slope that is actually increasing. There it is. That's a negative slope, and that's a negative velocity. What will happen to that velocity from here to here? It will stay the same. So this velocity will stay the same till here. That velocity will stay the same till here. It's whatever slope it attained here will stay the same because it's a constant velocity. Constant velocity, constant slope. Negative slope. Constant negative velocity is constant negative slope. Make sense? So you just have to inspect part by part and then you get the graph now. What happens from here to here? Is the velocity positive or negative? Is the velocity positive or negative? It's still negative. From a negative value, it is changing to 0, which means from a negative slope, it has to change to 0 slope by the time it reaches there. So it changes the slope, and finally 0. 0 slope. And what happens from here to here? It increases in slope. And what happens from here to here? It stays with that straight line. And then from here to here, it reduces slope once again to 0. Okay? And finally, it ended up here. Which means what? It started off from here and ended up having a negative displacement, which means the total area of this graph should be, you can see that. If you add this area and this area, you'll get a certain positive area. Look at this area. It's much bigger negative, right? So that means the overall displacement is supposed to be negative, and approximately we reach there. So this area is much bigger than the sum of these two. That is why you ended up with a negative displacement overall. So you have done all the equations of motion. Vf is equal to Vi plus At. Vf is equal to Vi plus At. Displacement is equals to Vit plus half At squared. Velocity or displacement, x is equal to Vf plus Vi over 2 times time. These are the two main equations. This one, you know where it comes from. Acceleration is equal to Vf minus Vi over time. From there you get this equation. And then we have x is equal to Vit plus half At squared. And we have Vf squared is equals to Vi squared plus 2Ax. So these are the equations of motion. Now, I write it with the simplest symbols because you can easily picturize this. Now, if you look at books, they won't call it x. Instead, they call it change of position. So instead of x, they'll write xf minus xi. I'm writing this equation in a different format. Is equal to initial velocity times delta t plus 1/2 a delta t squared. Now, look at that equation and look at this equation. It's basically the same thing. But to work with, when you look at that equation, you feel it's a big one. But when you look at this one, it's something that appears very simple. Yes, T stands for a change in time. That is correct. That is the right thing to do. But what I've seen is students get really worried about those equations and they end up making mistakes instead of just calling it as x and thinking about displacement as just x, whether it is in the y direction or x direction. Just x. And instead what they do is they call it as yf minus yi. If something's going up and down, they call it yi minus yf. It's unnecessary. What if it's going like this? It's a slopey road and it's going like this. What are you going to call it? I won't call it by any other special name, x. From one spot is going to the next spot, x is a displacement. Think of it like basic. And then you'll be fine with it. Okay? So I won't use these kind of equations, although they are the meaningful things. When I was taught, I was given these equations. And it actually makes it more complicated. Okay? So when I was learning physics in colleges, you know, one of the things that scared me was mechanics. First, the teacher. Like, he was going everywhere. And he was throwing all those equations which I could not comprehend. Like, I was not able to really grasp those things. So it was electricity, electronics, they were more friendly. Teachers were good. And this mechanics teacher was really creating hell for me. And I was like scared of mechanics. Guess what? When I started teaching, I had to relearn mechanics in order to teach. Now, teaching is a different story. So I had to relearn them once again. When I was relearning, I said, what? Why is this complicated? Why can't I just keep it like this? So from my day one of teaching, I use this. I check, okay, I don't want these unnecessary symbols to complicate the students. Straightforward, let's go for this. And I started learning mechanics to teach my students. And after 1 year of teaching my students, mechanics was my favorite. It just changed over because I studied it myself. And I formulated those things myself. And I said, okay, now I get a full grasp of mechanics. Now give me any problem in mechanics, I can solve it. You know, that sort of confidence. So yeah, it depends on the teachers. It depends on so many factors. Some of them can scare you. So it's a kind of information for you in future. When you go to colleges, you may be sitting in, you'll be one of 200 students sitting and hearing the lecture. Teachers may sometimes throw you off completely on a certain topic and scare you. What do you have to do? Learn it yourself. There are many resources these days. Just learn everything yourself. Okay? That's what I told my son when he went to college. Like he got a 5 on AP Physics. He was a junior and senior. When he went to college, he had the option of skipping both physics at college. And he was like thinking like, should I really skip both or should I skip only one and then take the electricity and electromagnetism and all those things? Should I hold on to one part? Because skipping both, he felt like he's going to miss something, which the others will gain. And so he ended up skipping only one part, which is mechanics part, and he went for the other one, and he regretted later because it was pretty much the same thing as electrostatics and all that that we cover in physics senior year. And the thing is, the way the teaching was going on was there was no contact at all, and he couldn't understand whatever was going on. It was throwing him away. He felt like as if he does not know any physics. That is the feeling he got. And he was worried about it. He came and talked to me about it. And I said, don't worry about the teacher. Just ignore, just find out some important words that he's using. What topic is he talking about? Make your own notes. You make your own notes and prepare. And that's what he did. And he aced the class. He simply sat with books and made his own notes. And then in the class, he was just sitting there just to find out what is the topic that's going on. That's it. He doesn't want to listen to it. Just the topic. Okay, is he talking about Gauss's law? Fine. Gauss's law. I'll look up about Gauss's law and learn it myself. And that was really successful for him. And he got really good score. So everything matters. So mechanics was my really scareful subject, and then suddenly it became my favorite. Well, everything is good for me. There's no special subject that is really my favorite now because all of them are. There's nothing that's really supposed to be troublesome to students. It all depends on your level of understanding of each one. So let's see where you're having more issues. Mechanics is one of the harder topics. Remember that also. Mechanics is one of the harder topics. If you're going for mechanical engineering, you're going for challenges. But it is not something that is impossible. Because, yeah, mechanics requires you to think of situations, apply it more technically, and so on. There's more technical application in mechanics. Anyway, these are the equations of motion. What term is missing from here? What variable is missing? X missing. What's missing here? Acceleration missing. What's missing here? Final velocity missing. What's missing here? Time missing. And you can see one thing that all of them contain VI, 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 VI. So VI, the initial state of motion, is supposed to be something that is important. Is it starting from rest? Is it moving with a certain velocity? Those are things that are important. So sometimes you may be asked for VI. You may be given this, you may be given this, you may be given time, and you're asked for VI. That's possible. That's possible. What should have been the initial velocity for that motion? That's possible. So you can see here there are 4 variables in all these equations. Out of the 4 variables, if you have 3 of them, like if you know this, this, and this, you can figure out the last one. So for any equations of motion questions, all you need is 3 pieces of data. Once you have 3 pieces of data, then what is being asked is the 4th one. And what is not mentioned in the problem at all is the 5th one, which is this. And so you pick the right equation. Yeah.
I remember on mastering there would be some questions that would have multiple parts. So like at first I would only know like 3 of the variables and have to solve for a 4th one. But then once I knew all 4, I would have trouble picking out which ones
Which
to
one to use.
which equation.
Normally when you have all the 4, which was the last one you discovered, don't use it. You can try not to use it and then use the one which is given to you and work on. That's what I will do. For example, if you use this to find the time, and then if you want to find the displacement, I will not use that time that I solved from there. Instead, I'll think fresh about it. Right? You understand? So VF is given, VI is given, acceleration is given. So if you want to figure out something else like X, you can use the information. Like if I'm going to use this, I need the time, but I'll use this to find the displacement. You understand? So I'm not using a previous answer. What if the previous answer is wrong by itself? Suppose you knocked on a wrong answer, the previous one, then everything else you're going to get it wrong. So I won't use an answer that I just got in the previous step, but I will think fresh about it. Every problem, every question has to be thought fresh. Yeah.
What is equations beyond the test? Like,
No, you need to memorize it. You need to memorize the equations of motion. So you should, no, after doing so many questions and so many practice questions, you will automatically memorize this. As you can see, this is not a big challenge. This one comes from the acceleration definition. Cannot forget it. This one is average of the two velocities times time. That is not something that you will forget. Now, this equation you'll be using multiple times. So it'll, even in your dreams, even in your sleep, if someone just asks you, what is x is equal to? You'll say VIT plus half a square. I mean, it just comes like that. Depends on usage. That one is also not that tough an equation. So as soon as someone starts VF square is equal to, then you'll continue the rest easily. It just flows. Okay. Again, it depends on how many times you're using it. So now, if you don't remember the equations in a test, I'll give it to you, but I'll take away some points. It's better to give you the right equations so that you can work on all of them properly, rather than you choosing a wrong equation and getting everything wrong. Do you get it? So I'll give you, in case you say, no, I give up, I cannot remember those equations, and I give you those equations. That's fine. So let's go through some of the problems. Let's say I'm standing on top of a building. I'm standing on top of a building. Okay, and I'm standing right there at the top of the building, and I'm throwing an object. I'm throwing an object vertically upward with the velocity of what to say, with the velocity of 20 meters per second. So I'm throwing it standing on the top of the building with the velocity of 20 meters per second, and it comes back to me. I catch it. How long did it take for it to come back? That's a question. So you understood the question right there? I threw the object upward at 20 meters per second and it reached my hand. That's all I'm saying. Can you pick 3 pieces of data from whatever I stated? Yes. Good. So what you have to do first is draw the diagram. Any physics problem, you draw the diagram. Once you draw the diagram, have the problem solved. And on the diagram, you can actually put indications of, or what is it, 20 meters per second, right? So we have the initial velocity, 20 meters per second, positive, negative. Because you're throwing it up, positive. So remember this, when you talk about velocity, initial, final, acceleration, displacement, think, is it positive, is it negative? Is it positive? Okay. Now, what else? We have our acceleration. What is the acceleration when it's going up? What is it coming down? -9. What is at the very top? -9.8. Final velocity is 0, but acceleration is never anything other than -9.8. Okay? Never think of a positive acceleration or 0 acceleration when the Earth is controlling the object. It's always. So always acceleration is -9.81 meters per second square. So we have that. What else do you know? We need to, yeah, but my question is to find the time. So again, for every problem, you need to know where is it starting from. Well, it's starting from here. Where is it finishing? It's finishing here. So this is my starting point, this is my finishing point. Between the starting point and the finishing point, you have to pick up the data. Not at the very top. Okay? This is the starting point, this is where your problem finishes. So between those two, initial velocity is 20, acceleration throughout the motion is negative 9.81. One more piece of data. Displacement is 0 because it came back to your hands. Now some of these piece of data, it won't be clearly mentioned to you. Like I just threw this, came back to my hand. I didn't mention to you that displacement is, you have to understand certain things. Got it? Look at the scenario and find out, oh, in this case, displacement must be 0 because it reached the same spot. Yeah. It's like touching the nose. Instead of touching the nose like this, you go all the way. Yeah, there are some people who do problems in stages, like doing from here to here and then adding to this from here to here. Or if I give you more stages, then you do that, then you do this, then you do this. Don't break it up. One equation can solve all problems. Okay? So we are only interested in this initial and this final, not that. So we have this piece of data. What is wanted? What are you looking at? Time. What equation will best fit over there? Which is the data that is not given to you? VF, which is the final velocity of impact on my hand. I don't know. Okay, we can guess, but I don't know right now. Nothing is, you cannot take anything for granted. So which equation is best fitting here? See, write the data, draw the picture, write the equation. I know this equation by heart, but I write it again and again and again. As students, you should practice this, right? Because I've seen some students thinking about the right equation, but then no equation, they're just floating the numbers in midair. So VIT plus half AT. By writing this multiple times, you get used to it also. Yeah. No, we are solving for time. We are solving for time. We don't know anything about final velocity. The final velocity is missing, so we pick up this equation where final velocity is missing. And so what is displacement? 0. Initial velocity is 20. Time, we don't know. Now, this is plus half of negative 9.81 t squared. Now, look at this. It's going to come into literally all the problems. In future, I'm not going to write this all the time. Instead, I'll write straight away when I'm substituting, I'll write minus 4.905. I'll just write this straight away because I know it's half of negative 9.81. So if it is negative 9.8, if they give you 9.8, then just write negative 4.9. Much simpler. So once you do this, what you can do after this is purely algebraic steps. Add 4.9 t squared to both sides, so you get this. And then divide both sides by t, you get this. And time is equal to 20 over 4.905 over. How much is this? 4.070.
4.077.
Okay, so 4.08 seconds. So it took 4.08 seconds for it to come back to my hands. One shot, one equation, you reached your final answer. Okay? Now redraw this situation again. Redraw the situation. Now this time I'm giving you 50 meters is the height of the building. Now this time I failed to catch it. I threw it up hoping to catch it, but it didn't come to my hands and it went all the way down to the ground. How long did it take? How long did it take from here to your final point, which is there? Look, we are not taking anything else as a final point. Starting point is here. Where did it finish? Here. And I want the time for the entire journey. And therefore, initial velocity is plus 20. Acceleration, you know for sure, is negative 9.81. Time is required. Displacement is negative 50. Good. See, that is something you should be careful. Oh, it started here and ended here. So what displacement did it go through? A positive displacement or a negative displacement? It's a negative displacement. Put that right. And then, yeah, we got these three pieces of information. Which equation is going to help? The same thing. So x is equal to bit plus half at squared. Negative 50 is equal to 20t minus 4.905 t squared. Yes.
So you want us to solve for time again?
Yes. So what you do is move them from one side to the other side. So if I bring everything to one side, I get 4.905 t squared minus 20t minus 50 is equal to 0. The equation turned into a quadratic format. Now, yeah.
Wouldn't the 50 be positive if it's on one side?
No, I just shifted this here.
Oh.
Okay. Yeah, you should be double checking everything. I may be going wrong. So you should double check and find out if it is positive, negative, and all those things. Now, this one, I know most of you have the quadratic equation function on your calculator, the program, but technically I'm supposed to raise all of them before the test. You understand? You cannot run any programs on your calculators because there are some students who don't have the programs and they'll be, doing it the normal way. So having a program on the calculator is not acceptable. It's considered cheating. I'm not going to do all the checking and all that, but make sure you don't use them. Why using a program is sometimes dangerous is because a small corruption in the program, which can happen easily. Anybody presses the program and then somehow goes to the edit, and then a small bracket is missing, or some small thing is gone, and then the program is going to spit out wrong answers. In that case, you have to go back to your basic method of solving quadratic equations. So if you know the basic method, it should not take much time at all to do that. So for your ACT also, the programs should be cleared. Normally all physics teachers and math teachers, they clear the programs and reset it so that you don't use anything standard, because someone can actually put equations into it, which is not correct. You understand? So don't put equations and all that and think you're smart. No. That's a form of cheating. And instead of that, try to work with the equations and then you'll be good at it. So how do you solve for t using the quadratic functions? The equation is minus b plus or minus root of b squared minus 4ac over 2a. So that's exactly what I'm going to do here. Minus b. What is b? Negative 20 is b, and so minus b is just 20. Plus or minus root of b squared minus 20 squared is 400. And then minus 4 times this times this. So there's a minus already here, so it becomes plus. 4 times this is 200. 200 times this is going to be 981 over 2a, twice this, which is 9.81. So now we have 20 plus or minus. What is square root of 1,381? Square root of 1,381. 37.2, and then over 9.81. You know that time cannot be. So if an answer for negative time comes up, you just throw it away. Time should always be positive. So yeah, use only the positive thing. So 57.2 divided by 9.81 gives you the answer straight away. 57.2 divided by 9.81. 5. The total time taken for the entire journey is 5.83 seconds. This is a much faster approach than splitting it up into this from here to here and then find out the height, and then from here to here. All that is unnecessary. Instead of doing 3 equations, just use 1 equation. Yes, sometimes you bump into a quadratic equation, solve it. And using the quadratic equation, I mean, that's something that's going to be useful everywhere. So if the programs are corrupt, or if you're going to use a calculator, which does not have the program, you're going to be stuck there. Suppose you don't have a calculator, and then I give you a calculator, doesn't have the programs on it. So yeah.
But we need to memorize that quadratic formula.
I suppose it's already memorized. Haven't you used it already? Never? I mean, I think from the freshman year, you will be knocking on that equation. You'll be using that equation freshman year, sophomore year. So no excuse. You cannot say that you forgot that. Anything you learn in math should be kept. Don't think that that is just for math. It is something that will be useful in many other branches. You may have to do a chemistry solving equations. You may have to do lots of problem solving in physics. And if your math is forgotten, if I ask you, okay, now what's the LCM of these two? LCM. Oh, I forgot. I thought it was only in math. No, it's everywhere. So you cannot just ignore some of the things that you have studied in math. Basic math, algebra, very important. Okay, so don't ignore that. Yes, if you don't know that one, memorize it. X is equal to, and what is the quadratic equation format? Ax squared plus bx plus c equal to 0. So x will be that. Okay. Understood how to solve this? Yes. Good. Now, if my question is, how high did it go? The question is, how high did the object go? Which means, what is the height it went to? Now, where is the starting point? Here. Where is the finishing point? Up there. That's it. I'm not concerned about anything else. So journey starts here and ends there. Between those two locations, what do you know? We know the initial velocity is plus 20. So you're finding the maximum height. So the equation is this: acceleration is minus 9.81 meters per second squared. Displacement is what you're looking for. That is the displacement that you're looking for. Yes. Very good. Final velocity for sure is 0 because it is turning around. And you cannot, for this problem, take, oh, we already discovered the time is 4.08 seconds, so time should be 2.04 to go up. That is an assumption. You don't guess anything. If you are using something like that, you have to prove that it is 2.04. Okay, you can't just guess. All right, but VF is 0 for sure. Yes. It's a long work again. It's a longer work because it's not that easy. You're changing it into fractional steps. That's not necessary. So here, what variable is missing? Time is missing. So we don't want the time. Which equation is not having time? Vf squared is equal to Vi squared plus 2ax. See, it's much easier to write just x instead of xf minus xi and all those things. And when you know the displacement is upward, it's positive. But here the question is, so 0 is equal to 20 squared, which is 400, and plus 2 times negative 9.81 times x. So x, so 19.62 x is equal to 400. What is x is equal to? Yes. 20.4? 20.4? 20.4? Problem solved. You don't think, huh? No, this is the height from the top of the building. If the question was, what is the maximum height from the base of the building, then you add 50 to it. Okay, it depends on the question. Okay, copy. Now I want to know the final velocity of impact here. I want to know the final velocity. So now my starting point is here and ending point is here. Between those 2 points, write down the data. What is it? Minus 50. And what is required? VF is required. And time is not my concern. Although I know the time, right? 5.83 seconds. I know the time, but I'm not using it here. I have got already the variables required. So again, VF square is equal to VI square plus 2AX. VF square, that's what you're trying to find out, equals to 400 minus 19.6 times 50, or negative 50. So the two negatives makes it positive. So VF square is equal to 400 plus 9.81, or 981. So VF is equal to square root of 1381. What's the answer? $37.2. Is that right?
Yeah.
100% right? And if I say no, if you leave it like that, it means positive. When you actually solve, when you take a square root of something, you have two options. It could be plus or minus. Now, which one is correct according to your logic? Look at this. It's on its way down. So negative is the answer. So VF ultimately is going to be negative 37.2 meters per second. Now, if you said positive 37.2, it means it's going up. While it's hitting is going up. That's not possible. So you have to think of the right stuff and see how quickly you finish the solution. Fast. Next. Where is the object? Where is the object at 5 seconds? Where is the object at 5.00 seconds? Exactly after 5 seconds of throwing the ball, where is it? That's the question. So now these two stay the same. Where is it? So that means x is equal to what? And I give you the time. Now which equation will be best fitting there? Exactly. X is equal to VIT plus half AT squared. And then substitute. VIT 20 times 5 minus 4.905 times 25. Just work it up. 100 minus negative 22? No. Negative 100 and? It's been, oh, the answer you said?
Oh, yeah.
Oh, okay, okay. So what is this one? And then your answer finally becomes negative 22.6 meters. What does the sign negative here imply? That it started here, and at 5 seconds, it is at a displacement of negative 22.6. That means it's right there. It's right there at that spot. So the answer tells you more information about what's happening. So the object went with the positive displacement but came back after 5 seconds, it was right there. And you know the total flight is 5.83 seconds. So which means 0.83 seconds it traveled all this. Okay? Clear? Next one. At what time is the object at a height of 10 meters from top of building? At what time is the object at a height of 10 meters from the top of the building? You want the precise time. Yeah? Yeah, 10 meters above, right there. So this is the top of the building, 10 meters above. What time is it there? So we know the displacement is positive 10. And the question is asking for time. Again, which equation? X is equal to VIT plus half AT squared. See, after writing it so many times, it just flows again. That's why I'm asking you to write the equation down before you substitute. 10 is equal to 20t minus 4.905t squared. Change it into a quadratic equation. 4.905t squared minus 20t plus 10 is equal to 0. Using the quadratic equations, minus of b, so 20 plus or minus root of b squared, 400 minus 4 times this times this. 4 times this times s is 196. Divide by 2a. Tell me the answer. What is square root of 203.8? So, what answers do you get? The time. Yeah. 3 point. So right, first 3.55 seconds. 3.49. Say one answer. What about the other answer? Is it negative?
No.
0.5 what? So which time will you accept as the real time? Which one? Which one is the right time? Both are right. They're both positive. Why do you knock off one of them? You knock off only one which is negative. No, both are positive answers. So both are right. How come both are right here? Yes. No. This time is the time when it was on its way up. This time is when it's on its way down. So both the times there are 10 meters high. Do you get it? At both times. At this time it is at 10 meters. At that time it is at 10 meters. So this is 0.58 seconds. That is 3.49 seconds. Both are right. You cannot knock off any one of them. Yeah. Say it again. If you choose positive, it will be 34.3 divided by 9.8.
Oh.
If you choose negative, it's going to be 6.7 over 9.8.
Gotcha.